Alright, let's get started. It's 7 o'clock. So we'll start with review. I gave you quite a bit of homework, but I said to do the odd ones. So we'll start on page 339. If you did all of them, that's great. I'm going to go through even and odd. I just didn't want you to have too much work to do. But if you're able to do that, that's great. So let's start. Let's see. Started with just simplifying polynomials. Page 239, number 1 through 20, I think everybody understood, right? The like terms or unlike terms. Was there any confusion there? Yeah, it's okay. All right. Just do number 21. One said. It's difficult. Here's 21. Simplify each expression by combining like terms. So there's 3x squared y plus 4x squared y, right? What we need to look at is, if you remember, each of these is a term, and when we simplify, we find out what are the like terms. And the like term has the exact same variable, and the power of the variables is the exact same. It's the exact same variable combination. The coefficient is the number in front.
Yes.
If there's no number in front, then the coefficient is a 1. Okay? And if there's no variables, then it's a constant. Right, so this one, are they like terms or unlike terms?
Like terms.
The like terms. It's an x squared and y, and x squared and y.
Yeah.
So these are two like terms, we can put them together.
Yeah.
Basically add the coefficients. So this one's 3 and this one's plus 4.
7.
So 3 and plus 4 is 7. That'll be 7x squared and y.
Y.
Alright? Any questions on that? Good. Let's see, number 28. Let me just see if there's any others that are possibly confusing. We'll do 27 first.
Okay.
So 27,
7G
7g
plus 7GH
plus 7gh
plus 7G
plus 7g
plus 7GH.
plus 7gh. Oh, okay. So we need to find the like terms. Right, so this is a G, this is a GH, this is a G, this is a GH.
Yeah.
Right, so the G and the G and the GH and the GH.
Yeah.
So we add 7 and 7.
14G
Yeah, so that would give us 14G
plus
the same, 7 plus 7.
14GH.
14GH. Any questions on this method? This is a basic method. They're going to get a little bit harder as we go through. Alright, so we'll do number 28.
G squared
G squared, yeah,
plus H squared
plus H squared
minus 4G squared H squared
minus 4 G squared H squared.
Yes. Plus G squared plus H squared
Plus H squared
minus 4.
minus 4. Okay. Yeah, so this one could be confusing because you have 4s that are the same, and G squareds and H squareds. But it all depends on what is the variable combination, right, in the term. So this one here, we have a G squared and an H squared. We have a G squared, H squared, and again we have a G squared and H squared, and we have a constant.
Yeah.
Right? So any constants you add together, and the others we add the same. So here's G squared, and here's G squared, but they don't have coefficients.
Yes.
Right?
2G.
So it means it's a 1.
Yes.
Right? So G squared plus G squared?
2G squared
2G squared
plus
again with the H and H, that's a 1 plus a 1.
2H squared.
H squared, okay. And now we have G squared, H squared. Do you have any other G squared, H squared together?
Yeah. Yeah. Minus.
Yeah, we don't have any more G squared and H squared. So
Yeah.
we just keep this term.
Yes. Minus
Minus 4
G squared H squared
G squared, H squared.
minus 4.
And we just put the minus 4 there. Yeah. Any questions on that? The beginning of confusion could have been a little bit like, there's no number here, so what do I do? If there's no number, it counts as a 1.
Yeah.
Okay? And again here, the constant, this is just, anything that isn't added just carries through. You could do the distributive property to pull the minus 4 out, but when we're simplifying, we want to leave it as all terms. We don't want to have any brackets. Because sometimes the brackets are maybe Like once you add the brackets to get like multiply out the brackets, you'll get a term that's already here, and you have to add it. So we kind of want to get rid of all the brackets when we simplify. All right. Any other questions on this? Let me just do. I'll do one more of these ones. Number 33. It's pretty long, right?
Yeah.
8x squared
Yeah. Minus 4, right?
minus 4x
Plus 7
plus 7
plus 4x to the power of 3
plus 4x cubed. Yep.
minus x squared
Minus x squared
plus 7x
plus 7x
minus 2.
minus 2. Alright. So in some ways actually this is a bit like the adding polynomials. You can see this is the polynomial and this is the polynomial. But it's actually just one whole chain. And we need to find the common ones. So we have x squared here
Yes.
and x squared here, right?
Yeah.
We have x and x.
Yeah.
We have a constant and we have a constant here.
Again.
Okay? And then here we have x cubed.
Yes.
So there's x cubed. Now usually what we do with these kind of problems, I haven't quite done it here. Well, these are all the power of 2. But we write the highest power first. That's the normal way we do it. Now, in these problems, I don't think they're necessarily asking for it, but often you'll be seeing a solution. It'll start with the highest power first. And some, I saw in the Khan Academy stuff, the links that I sent to you guys, he actually was teaching about writing the highest power first. And if you were putting the answer in, you had to do it with the order of the highest power. So even if it was the correct answer, but you didn't do it the highest power first, it would count as wrong. I don't know if any of you tried the Khan Academy exercises, but it's very specific to do it. Because he's looking, it's a computer, right?
Yeah.
So unless you write a really complex thing that can do multiple answers, unless it's the exact right answer, it will not be able to read it. Hi, welcome. So we'll start with the x cubed. So here, 4x cubed. And next will be the x squared, right?
Plus 7.
So we have, yeah, so first we determine it before I know if it's a plus or minus.
Yes.
So we have 8x squared here, and minus x squared.
Yes.
So minus no constant, it's minus 1.
Yes. This plus
So
7.
8 plus minus 1 becomes 7.
7.
So plus 7x squared.
Yes.
And then our x's, yes, so we have 7x here
Yeah.
and minus 4x here.
Yes.
Right? So this is plus 7,
Plus 4.
and here's
plus
minus
3.
4.
Plus
Okay, so it's minus 4 plus 7. Alright?
yes.
So if they're different signs, we find the difference.
Yes.
Which is basically the biggest number minus the smallest number.
Yeah.
So 7 minus 4 is 3.
Yes.
And then whichever one has the highest sign,
Yes.
we use that sign. So it's 7 minus 4 is 3, and 7 is the highest sign, so it's a positive.
Yeah.
Okay, so it's plus
4, 3,
3x.
yes.
Yeah, I'm going to just erase this.
Yeah. Plus 5.
And yeah, now do the constants, the same thing. Plus 7 minus 2, difference is 5,
Yes.
and 7 is bigger. So plus 5. Right, so I'll put underline so you can see it. Yeah. Any questions on this? No? Then I'll take a picture of it, send it to you guys. 36 and 37. Did everyone get that? Alright, number 36. Number 36, we have, okay, it's basically the same idea. 3a squared b, right?
Yes.
What else?
Plus 4ab
4ab
plus 3a squared b
3a squared b
plus 5ab.
plus 5ab.
A. Yes. AB.
Right, so this is actually the same thing.
Yes.
We just find common terms.
So 4 is the a squared.
This one?
This one, yeah.
Wait.
No, it's not.
No.
Oh, it's not?
No.
You are not.
Four
You are
A.
not around.
Number 36.
So,
Do you have a book?
No.
You can use the other guy who can show you his book. So you can be completely sure if you don't trust any of us. Yeah. Okay, so the same idea, right?
Yes.
Common, this is a squared b,
Yes.
a squared b. So it's 3 plus 3.
6
So that equals 6 a squared b.
B.
And then we have ab and ab. So it's 4 plus 5.
9 AD.
Plus 9 a. Is that one of the options?
Yes.
Good. It's always
Number B.
reassuring when you get one of the options, but not necessarily, because they often will try to trick you, right? Okay, number 37. A little bit different. This one asks how many terms, right?
Yes.
So j
J
squared,
squared plus K cubed
k cubed,
minus 2J cubed
2j cubed,
plus 5K cubed
plus 5k cubed,
minus 2J squared.
plus 2j squared. Okay, the question is, how many, when simplified, how many terms?
5.
Okay, so total we have 1, 2, 3, 4, 5 terms, right?
Yes.
The terms are everything that's separated by minus or plus,
Yeah.
right? But we're going to be simplifying it.
Yeah.
So what we need to find out, we don't have to actually simplify it. All we need to do is find out how many unlike terms are there, right? How many unique unlike terms. So there's j squared and j squared.
Yeah.
So j squared is one of them, right?
Yeah.
There's k cubed and k cubed, so that's another one.
Yes, another one.
And then we have k, and we have j cubed,
Yes.
the third one.
Yeah.
So we have three
Three
terms, basically, when we simplify.
Yes.
We could do the work and simplify it, but you don't need to. The question's just asking how many terms, so don't do more work than you need.
Yeah.
Find your answer and move on, because it's a time test.
Yeah.
Okay, so 3. Yeah. 3. J squared, k cubed, and j cubed. Okay? I'll put a little...
I think minus.
Doesn't matter. I don't care what the coefficient is, right? I just want to know the unique term. The coefficient can be minus, the coefficient can be 3 over 10.
Yeah.
Doesn't matter, it's just that's the variable.
Okay.
Right? Okay. Any more questions on this? I think this one is pretty simple, number 30, page 339. This is page 339. Alright, now we'll do 341, adding polynomials. In some ways it's good that you're getting a lot of practice with these ones. This book is really giving you, a lot of repetition so you can get them. Let's look at page 341. Sinead, did you have any ones that you wanted to look at?
No.
No? Okay. Just want to make sure, because I wrote from everyone else earlier. And Laura also? You okay with these ones? If there are any more, just let me know. Pardon? Okay, you'll see on the next page? Yeah, I put many, because I think someone said they had some trouble with subtraction. So I'll do a bunch from here, and you can let me know what you want. But let's start with number 17 from here. So we're adding these polynomials, and then we're subtracting polynomials. And the other page was more complicated. Let's just do one adding, and then we'll do the sort of the subtracting. So let's say number 7.
Minus G. Minus
Yeah,
8G
so the
squared
bracket, minus 8g squared
plus 7G
plus 7g
plus 6.
plus 6
Yes. Plus bracket
plus, yeah,
plus 8G squared
8g squared
minus 7G
minus 7, oh my, okay,
minus 5.
minus 5. Okay, I know where this is going already. Okay, so when we do this, the thing is when we're adding them, when you add polynomials, it's very easy. You basically just take away the brackets, and it's a whole long problem, right?
Yeah.
So this then becomes minus 8g squared plus 7g plus 6 plus 8g squared minus 7g minus 5. And in fact, you may not even need to do this step. If you can do it quickly, you can do it straight from here. Because you'll see, minus 8g squared plus 8g squared, 0. They cancel each other, all right? So I'll just do a line. All right? 7g minus 7g, also 0. So now we just have 6 minus 5.
Minus 1.
Remember? 1. Yeah. Equals 1. Okay? I'll simplify it. Equals 6 minus 5, which equals 1.
1.
Okay. Any questions on this?
Okay.
No? Good? Okay. Then going on to subtracting, let me just do number 11 before we do number 17 to make sure we're on the right page.
Good.
3y. 3y
Minus 4.
minus 4
Close bracket. Okay.
minus 2y
minus
minus
2.
2. Okay. So for this one, the important step is basically the negative goes through,
Yeah.
right? So every term gets multiplied by negative 1.
Yes.
So it becomes, this then equals
3y
3y oops, minus 4. Now minus,
2.
so minus 1 times 2 is minus 2.
Minus 2
So minus 2y.
Plus
And minus 1 times minus 2
plus 2.
is 2. Remember, just flipping. Minus negative. Or so up here, we
plus
start
2.
negative. Yeah, it changes. So it's plus 2. Alright, and now our common terms, we have a y, 3y, and minus 2y.
Y.
So 3 minus 2 is just y.
Y.
That's right. It's y. I don't write the 1 because I don't
Minus
write
2.
1s. And then we have minus 4 and plus 2.
Minus 2.
So it's minus 2. There you go.
Very nice.
Y minus 2. Any questions on that?
Um,
This is how we're doing them. And I'll do number 17. I'll start on the ones that you guys talked about. Pardon? Those are number 14? Okay. Yeah, sure. All right, number 14.
yes. 5x squared
5x squared, yeah,
plus 2x
plus 2x
plus 4
plus 4
bracket minus
minus
2x squared
2x squared
plus x
plus x
plus 2.
plus 2.
Yes.
Okay. It's going to be the same thing.
Yeah.
It goes through and this will just become all negative.
Yeah.
So that equals 5x squared plus 2x plus 4 minus
2x
2x
squared
squared
minus
minus
x
x
minus
and
2.
minus 2. Now again, you could probably skip this step. You could just say like I'm doing x squared minus this, x minus x, 4 minus 2. But if you're all going to get confused by that, do it step by step just to make sure.
Okay.
Especially when you're learning it. Like the time to speed is not now. Now's the time to learn and make sure you get the concept.
Yeah.
And then once you really have the concept, then you can practice taking shortcuts for the test. Okay, so we have an x squared and x squared.
Yes.
So 5 is minus 2.
3x
3,
squared
that's right.
Square.
So this equals 3x squared. We have a 2x and
Plus-
negative x, which is
plus
minus 1, right?
yeah. plus x
So 2 plus negative 1 becomes 1.
1x
X.
plus x
So just plus x. We don't write the constant.
plus
Oh, we don't have the coefficient.
Plus 2.
And it's 4 minus 2
2.
Plus 2.
plus 2. Although again, are these negatives making sense to you? You're saying like you want a little bit more on it. I just want to make sure when you're doing the 4 plus minus 2, that works? If the standard, you're looking for the difference.
Yeah.
Okay, good.
I think you have to go a little bit slow because I don't understand
You didn't understand which one?
the 11. Give me here plus 2 and
Number 11?
number 11.
Yes, because the negative outside, so minus and minus 2 becomes plus 2. So So for number 11, it was what? 3y plus 4 minus 2y minus 2, like this or something? Or is it minus?
Minus 4.
Minus 4, yeah. So what's happening is this minus multiplies through.
Yeah.
So if there's a positive here, it becomes minus. Right? This becomes minus 2y.
Yes.
Right? This is the same. But then here it's minus and minus.
Becomes plus.
So negative 1 times negative 1 is 1. Right? So it's negative 3 times negative 4 equals 12. It's a positive 12.
Yes.
Right? Negative number becomes a negative number because it's a positive number. So what's happening here is we actually, you can't see it. It's a minus 1. Pardon? We're multiplying because we're subtracting the whole thing. Okay, but it's in brackets. And now when we're getting the terms outside of the brackets, we multiply whatever the coefficient of the bracket is through the whole thing. Okay? And then if it may help, we can substitute some numbers. Okay? So say y equals 3. Right? If y equals 3. So minus 2y minus 2. Right? If we put that, it's going to be minus 2 times 3
Yes.
minus 2. Right?
Yes.
Which is going to equal minus 6
Yes.
minus 2,
2.
which is minus
4.
4.
Yes.
And this becomes just minus 4. Okay? Or if I multiply it through, right, what you can see is it's kind of like minus 2y plus 2. Right? And then this becomes minus 2 times 3 plus 2, which is minus 6 plus 2, which is minus 4. Or if you want, I can do it through here. I can go from this point here. So if we have minus 6 minus 2, right? Right, this is where I've substituted this in. I move this negative through, right? So basically this is a 1
1.
over here.
Yes. 1.
Alright? It's like it's kind of an imaginary 1.
Yes.
Imagine, it's the same as when there's no coefficient, it's a 1.
Okay.
So it's a minus 1
Times
times 6 and minus 1 times 2. This becomes negative 6 plus
Plus
2.
2.
Okay? Which equals negative 4. See what's happening? Yeah. So it's basically, when you have minusing the whole polynomial, you essentially bring it down, and essentially what you're doing is every sign in front of every term, it changes the sign. So if you multiply negative 1 through the whole polynomial, every positive becomes negative and every negative becomes positive. Because it will flip the sign, basically. It's as if, say, this line is on, and this line is off, and that line is on, right? We switch them all. This one becomes off, that one becomes on, this one becomes off. It's the same, like this one is positive and this one's negative. We're subtracting, so we're switching them all. So this one becomes negative, this one becomes positive. Yeah, but I think it helps. Imagine there's minus 1 here. The same as the coefficient, if there's a negative x, right? It's actually negative 1x. We just don't see it. Because you could even, it's a bit complex, but you'd even imagine x could actually, I could say x equals y plus 2. And then you have to put in brackets y plus 2 and multiply through that. You will get problems like that. We'll get there. But you won't get those kind of problems. Okay. So right here, 3x squared plus x plus 2. And absolutely, please, if I'm not making sense, slow me down.
Okay.
And say, I didn't quite catch that. Because I didn't realize that I missed this for you guys. So I want to make sure you understand it. Alright, number 17. Number 17.
It's minus g
Minus g.
plus g
Oh, okay. Plus g.
minus 1
Minus 1.
bracket
Minus
minus g minus g again. Yes. Minus 2.
Okay, that's a bit of a weird one. Yeah, I'll just put a box around it. So the first thing is, because by a rule, right,
Yeah.
PEMDAS, we actually, if you can simplify the polynomial before we do the subtraction, it'll be easier. So here, in both of these, we have a g and a g.
Yeah.
Right, so the first thing I'm going to do is I'm going to simplify each polynomial
Yes.
before I do anything else.
Yeah.
Right? So minus g plus g.
0.
Right? Minus 1 plus 1 is 0. So these just cancel straight out.
Yeah.
And I'm left with minus 1.
Minus 1.
Okay, I'll keep it in brackets so it's only doing one thing at a time. This one is minus g minus g.
2 minus g.
Yeah, so minus 1 minus 1.
Yes. Oh, minus
Right?
2g.
If you add two negative numbers, it becomes more negative.
Yeah.
So you just add the numbers together and keep them negative. So minus 5 plus minus 7 becomes minus 12.
Minus 12.
Okay, so minus 1, remember, if there's no number, it's a 1.
Yeah.
Right? If there's no number, it's a 1.
Yeah.
There's no number, it's a 1. So minus 1 minus 1 is minus 2.
Yes.
So this becomes minus, we're going to leave it here, so it's minus 2g
2g minus 2.
minus 2, that's right. And now we'll pull this minus 2,
Yeah.
and each of these will change signs.
Yeah.
Minus 1 times minus 2 becomes positive.
Yeah.
Minus 1 times minus 2, again, positive.
Yeah.
So this equals minus 1, I'm just going to put equals,
Plus
plus
2g
2g, that's
plus
right,
2 plus 2.
plus 2. Okay? And we can simplify it as a constant here and here.
2g plus 1.
Minus 1 plus 2,
Yes.
2 is bigger, you find the difference, so it's 1.
Yeah.
So that equals, as you guys said,
2g plus 1 plus 1.
plus 1. No, because the minus 1 here,
No, exactly, plus 1.
plus 1, yeah. Any questions on that? This one, I think it looks weird in the beginning because you see all these g's, you're like, what should I do? But it's a lot easier just, if you can simplify the polynomial before you do the subtraction, it's a lot easier.
Yeah.
Already it came to this easy thing here. Alright, let me take a picture of that. 17. Oh. Right, number 19.
19.
19.
Yes, this 7b squared
7b squared
plus b
plus b
minus 8
minus 8.
bracket minus
Mm-hmm.
7b squared. Fine.
Number 19, yeah?
Yes. 19.
That's right. Yeah.
Yes.
Plus b
Plus 8.
Plus 8?
Plus 8. Yes.
The minus 8 or plus 8?
No, plus 8.
Plus 8. Okay, that's important.
Don't-
Because actually, if this was minus 8,
Yeah.
right?
Yes.
Then if you have everything the exact same here,
Yeah.
and everything the exact same here, it'll be 0. Because anything the exact same subtracted by itself,
Yeah.
the exact same, is always 0.
Right.
Right. Okay, good to see you. But it's not, so
It's not.
we'll go through it.
Yeah.
However, these are the same, and these are the same. So if you're going more quickly, you can probably just cancel these out straight. And you just have this and
Minus
this.
6.
But
Yeah.
I'm going to go piece at a time, just to make sure we're on the same page.
Okay.
So this will become 7b squared plus b minus 8. Easy.
Minus-
And now all the signs change, right?
Yeah.
So these are all positive, so they're all going to become negative.
Yeah.
So negative 1 times 7 is negative 7.
There's 7b squared.
Negative 1 times 1 is negative 1. Negative 1 times 8 is negative 8.
Negative.
Okay, and now that means these two cancel.
Yeah.
The b squared and 7b squared. And then the b here cancels.
Yes.
But here we have minus 8 and minus 8.
Minus
It's not
16.
0. Yeah,
Minus 16.
it's minus 16. Okay, any questions on that? It's nice and easy. All the variables cancel each other out, and that's just the constant. Which is actually a tool sometimes. At the later on, we're going to get to a place where you have two equations, and you can actually add the equations together. sometimes you can cancel out higher order variables to get a single what a variable actually equals. It's a tool to use for solving equations. But we'll get to that when we get to it. For now, we're just learning these the basics still. Okay, any questions on number 19? If not, let's do number 21. 21 says, what is the sum? Oh, it's just polynomials. Okay.
Yeah.
Same idea.
2xy
2xy
3xy squared plus
3xy squared
minus again. Go ahead.
minus 4x squared
y.
Alright, and then add
Plus, yes, 5x squared y minus 3xy squared plus 2xy.
2xy. Alright, so this is the kind of one you'd have in the GED. It has multiple choice answers at the bottom. So I could write it all out, but I'm just going to start adding terms at this point. Well, actually, no, I'll do it. So that equals, without the brackets, essentially the same.
Yeah.
2xy plus 3xy squared minus 4x squared y plus 5x squared y minus 3xy squared plus 2xy. Alright, so you have xy and xy, x squared, y squared,
Yeah.
x squared, y. Okay. So let's start with the x. We could do either making y the highest one or x the highest one. We'll do x the highest one, so put the x squared in the front. So here we have x squared y, and here x squared y. So the coefficient here is minus 4, and the coefficient here is 5.
X squared y.
So exactly, it'll become 1. Because minus 4 plus 5 is 1. So this equals
X
x
squared
squared y.
y.
And then the next one is going to be
2x.
xy squared.
Yeah, okay, yes.
Although actually no, we probably would put the xy in the middle.
Yeah.
So this is xy, and this is xy. Right?
Equals 4 x
So it's
y.
2 plus 2 becomes 4. 4
xy
xy, and then now we want the other y squared on the other side. Yeah. So that's this one. 3xy minus 3xy. So 0.
Yeah.
They cancel each other out. Okay, so we're just left with this.
Yes.
And is that an option?
Yeah.
Yeah, A.
A.
There we go. Any questions on this one? Just I like to, when I'm writing it, just cancel them because it's easier for me to see what's left. Anytime I see like these things. Okay, then we'll do 22.
Okay.
Have it here.
Five x squared.
Oh, so minus this time, huh?
Yes.
5x squared
Minus 2x.
minus which x?
Minus 2x.
There's 2x
Plus 1.
plus 1
Yes. Minus
minus
3x squared.
3x squared
Minus 3x.
minus 3x
Minus 2.
minus 2. Okay, so again we're going to rewrite it, and the sign here is like a minus 1, remember? There's no number, it's a minus 1, so it's just minus 1 times each of these coefficients. So this becomes 5x squared minus 2x plus 1. Minus 1 times 3.
Minus 3x squared.
Minus 3x squared. Minus
Plus.
1 times minus 3.
Yes. Plus 3.
Plus, remember, so minus 1 times minus 3. Negative times negative is a positive.
Yes. Plus 3.
Plus 3x.
Plus 2.
And minus 1 times minus 2.
Plus 2.
Plus 2. Is that making sense now, Rob?
Yeah.
Yeah? Okay, good. So now we do like terms. So x squared and x squared. 5 minus 3.
2x squared.
2. 2x squared equal. Then we have x's, minus 2x and 3x.
Plus x.
Right, so minus 2 plus 3 is 1.
Plus x.
So it'll just be plus x. We don't write the 1 as a coefficient.
Yes.
So then we have
Plus
1
3.
and 2.
Plus 3.
Plus. Is that one of our options? Yep.
C.
Yeah, C. Now you see here, on this option, they gave you B, was very similar, it was a minus x.
Yeah.
So some of these options are tricky. Like I first saw it, I was like, oh, B. I was like, wait a second, no, C. So you have to be careful.
Yeah.
Alright, it's just because it seems that you got the right answer, it doesn't necessarily mean you have. Alright. Any more questions on this page? Add and subtract polynomials. Then we'll do the more complicated ones. Next page, on page 343. It's similar, yeah, it's similar. It's a lot of practice of the same thing. So this past week you got a lot of practice, which is good. And if you didn't do all of them, it's also good. You can go back and do all of the even ones. Alright, so page 343. These are basically multiple polynomials. So they ask you to simplify. We'll just do you're right, you're quite right today. It's really similar. Were there anyone specifically you guys want to look at on this one? Because I just had some people say they found it difficult. But specific numbers, any? I'll do one from each section then.
There is no difference.
There's no difference?
Yeah.
Okay, let's do number 6.
Number 6. Okay.
It's 19 x, y, z
plus x
plus x
minus y
minus y
plus 3xy z
3x, y, z
plus 6
plus 6
plus y.
plus y. Okay, then you simplify it. Alright, so we have 1, 2, 3, 4, 5, 6 terms,
Yeah.
but not all of them are like terms. So we have x, y, z here,
Yeah.
and x, y, z here. Okay,
Yeah.
so we'll add these together. 19 plus 3,
22.
22, x, y, z. Good.
Yeah.
Okay, next let's do the x's.
Yeah.
Alright? There's only x here, and no other x's.
Yes.
Alright, so
plus
we just
x.
keep that. Plus x. Then we do y. We have minus y here, and a plus y here.
Zero.
Okay, so 1 minus 1 plus 1 is 0. So those cancel, and then we're left with just the constant, 6.
And plus
There we go. Any questions on that? It's the same kind of stuff. Alright, we'll do one of the adds then. From the next section. Let's do number 11. So it's got high powers.
Yeah.
It's about the same, but it's just
Yes. P to the power 6.
p to the power 6,
Yes. Plus p to the power 5
p to the power 5,
plus pq.
p cubed.
Yeah. Minus pq.
Oh, p cubed.
Yeah.
I heard cubed.
pq.
P cubed
Yes.
minus
Square.
p squared. Okay,
Bracket.
and it's a plus.
Yes.
What is the
2p to the power 6.
2p6
Yes. Minus 5. Minus p to the power 5.
minus p to the power 5?
Yes. Plus 3pq.
Okay, plus 3 what?
pq.
Just plus p cubed.
Yes.
Q
Minus q square.
minus q squared.
Yes.
Okay. Check that. That looks right. Okay, so it's adding, so it's basically the same thing as a simplification.
Yeah.
I'm just going to write it over just to keep it consistent. But when you're doing this, you probably don't need to do this step. Plus 2p6 minus p5 plus p cubed minus q squared. Okay, so we start with the highest one, which is the 6th, right? So p to the 6th, p to the 6th. So we hear There's nothing, so it's a 1
Yes.
plus 2.
Yes. 3.
3.
3 p to the power of 6.
So 3p
To the power of 6.
hextuple.
And
Right?
6 to the
We don't, basically, once we go beyond 3, we don't have a special word for it.
okay.
I guess 4 would be quadruple. Yeah, 4 would be quadruple. So you could say quintuple for 5, hextuple. But we really don't. We basically, once it's 4 and up, we just take to the power of whatever.
Quintuple is like French.
Quintuple is 5. You can, if a woman, God bless her, has 5 children at the same time, they're called quintuplets. Right? So it only happens when you have, what's it called? The fertility treatment, like the help. But they do have that sometimes. So they're called quintuplets. But just power of 5 is fine. Yeah, okay. So P6, P6. Next is P5, right?
P5.
So here's the one P5, and here's the other P5.
0.
Yeah, they cancel. This is plus 1, this is minus 1, they cancel. Nice. I'll just do that so we don't have to worry about them. Okay, and here we have PQ, and here we have PQ. Do they cancel each other?
2 PQ.
No, because one's positive and the other one's also positive.
Yes.
So it becomes 2, because it's 1 plus 1.
Yeah, plus
Plus 2. 2. Alright? And then we have minus p squared. There's nothing else.
No, there are one.
No, I don't know.
Here is
What
zero.
is it number 11?
Pardon?
PQ plus 3PQ. It's called Q.
where?
Q
Where
is
is
square.
that one?
It's not
That is
PQ.
2.
This one?
Yes. No.
There's another one and lost.
I think it's the first one.
Something wrong?
Yes.
Maybe.
Oh, 3 PQ.
PQ.
Yeah.
Ah.
You're right. It's 3 PQ
Yeah.
plus 3 PQ. So then 1 plus
It
3
is 4.
is
4
4
Yes.
PQ. And actually, I'm just realizing I should have done the P squared before I did the PQ. Okay, because we want to go down. If I started with P, we're going to go down in the order of P and then up. Like we go down P and then up Q at the end. So I'll start with this one, P squared. Right? There's no other P squareds. So we do minus P squared.
P square one.
And then we do plus 4
PQ.
PQ. Oh, that's looking like a G. Q. And now we have, in the end, minus Q squared. And there's no other Q's, right? Okay. One thing that might help is if you're doing a long chain like that, if you have a pencil and a pen, when you do each one, you can kind of maybe cross through them. And then you do the 5, and then you do the squared, and then you do the PQs. Because then you know what's left, right? And then you have only P left. You do each term, and then you're crossing out, so it's easy to find what's still left. That's one thing you could do. Especially for longer polynomials. Alright, that's number 11. I'll take a picture of that. Okay. One of the subtracts. Anything from, let's see, you said number 25 to 26. Anything from numbers 17 to 24? That was difficult for you?
17?
17, okay.
No, it's okay.
Yeah? We'll do it. We'll do 17. We'll do 17. Maybe we'll do 2. I think the subtract we want to do a little bit more. Just to make sure we get it. So it's
AB
AB
plus A
plus A
plus B
plus B
plus 6
plus 6
Bracket.
minus
minus N. 8AB
8AB
plus A
plus A
minus B
minus B
minus 6.
minus 6. Alright. So again, we'll just, this one comes down by the same way. AB plus A plus B plus 6. And now this goes through, so every sign will change.
Yeah.
Alright? So we become minus
Minus
B minus,
minus
so minus A. This one's a minus, so minus becomes plus B.
plus 6.
And minus becomes plus 6. Okay? So we're going to go through. We'll start with the A's. So A here and minus A here. So
Zero.
they cancel each other. There we go. And you know what? I'll do the trick that I was telling you. I'll do the purple. So then we'll do AB next. So we have AB here and minus 8AB.
Minus
right?
7 AB.
That's right.
Minus
1 minus 8 is minus 7.
Yes.
So this equals minus 7
AB.
AB. And I'm going to cross off the ABs. So we don't have to worry about them. And then we do B, yes.
Plus
So the
2
B here,
Yes.
the B here. This is 6, so I didn't write it. It's sort of hard to see. The 6 and the B is like similar, right? Yeah. Although some people write their B's like that too. Oh well. So we have a B here and a B here, right? So it's 2 B's.
2B
That's 2B
plus 12.
and then plus 12. That's right. If you want, I could have crossed off the B's. Not the 6 plus 6 is 12. Any questions on this? No? I'll do one more of the minuses. Let's do number 23.
Okay. C cubed
C cubed.
D to the power 7. This is the same. C cubed
Oh.
D to the power 7.
D to the 7.
Yes. Plus C squared
Plus C squared
minus D.
minus D
Yes. Plus 35.
plus 35.
Minus
Minus
2C squared
2C squared
minus 3D
minus 3D
plus 35.
plus 35. So already I can see that the 35 is going to cancel the 35.
Yeah.
Alright? I'm going to go through it straight, but that I already know I can see. The rest we have to just make sure we're doing it right. So, this is D cubed set D.
3
Yeah,
cubed
okay.
C
So,
cubed.
let's do this is C cubed. First, I'm just going to make sure I have everything right. So,
Yeah, okay.
plus C squared minus D plus 35. And now minus
Minus
times
2
plus
C squared
becomes minus 2C squared.
Yes,
Minus
plus.
minus
plus
plus
3D
3D
minus
minus
35.
plus minus 35. Okay? So the 35 and 35 are going to cancel.
Yeah.
We know that immediately. Okay? Because 35 minus 35 is 0. And here we'll start with this one.
Yes. C
C cubed
D to the power 7
7.
Yes.
Alright. And then we're going to do, we have C squared.
minus C.
Minus C squared.
Yeah, so here we have plus C squared. And here is minus 2
Yeah.
C squared, right? So
Yeah.
plus 1 minus 2.
Minus C
So minus 1, which was just minus.
squared.
Minus C squared.
Yes.
And then finally we have D.
Plus 2D
Here's minus D and here's 3 positive. So minus 1 plus 3
minus 2D plus
is
2D
plus.
That's 2D.
plus
Plus 2D. Alright, any questions on that? Alright, then I'll take a picture and we'll do 25 and 26. Alright. Let me get the WhatsApp. Okay. 25 and 26 are more of the same, right?
yeah.
Yeah. Okay.
Yeah.
Oh, wait a second.
Huh?
25. Oh, no, it's the same. It's the same.
Yes.
Yeah.
X
X
plus Y
plus Y
plus Z
plus Z. Nice and easy.
bracket minus
Minus. Okay.
yes
2x
minus 2x
Minus 2x?
yeah
Oh, yeah. Log to x squared. And minus negative 2x?
yes
Uh-huh.
plus 2y
Plus 2y
plus Z
plus Z. Okay. So again, I can say the z's are going to cancel each other.
yeah
That's straight up.
okay.
So I'll just write it out. So This equals x plus y plus z.
Plus
So minus
2x
minus 2
plus
becomes 2, positive 2. Plus 2x
minus
minus and 2
2y
is because negative 2y.
minus z.
And that's right, minus and plus because negative z.
Yes.
Okay, so the z's cancel. Here, plus z, minus z, they cancel. And then we have x's and y's.
3x,
So here's x plus 2x becomes 3x.
3x
3x, and here
Minus
y,
y.
minus 2y.
minus y.
Minus y, because 1 minus 2 is minus 1. Do you have that as an option? Yes. 3D. Any questions on that? No? Okay, number 26.
2g squared
2g squared
plus 3h
plus 3h
minus 5k
minus 5k.
bracket
Yeah.
and
Plus.
plus
Plus.
g squared, yes,
Okay. Squared
plus 2h plus 3k.
plus. Oh, it's plus and it's easy. Right? You just write it all again. Plus h minus 5k plus g squared plus 2h plus 3. Like I said, you don't need to do this step. You can go straight from here, especially if it's a plus, because it's just the same. But I'm just doing this just so you guys can see the full flow. Alright, so we have g squared
Yeah,
and g squared here, right?
yes, 3g squared,
Becomes 3g squared,
yes,
and then we have h.
yeah,
Yeah, 3h and 2h.
5h
That's 5h.
plus
We have minus 5k
minus
and
2k
3k.
minus 2k
Minus 2. Minus 5 plus 3 is minus 2. Is that one of our options? BG? Ah,
is b.
B. And actually, since this is a multiple choice question, when it does come time to learn how to take shortcuts, right?
Mm.
If you see here, you could just look at these and do the first one, the g squared and the g squared. There's no other g squared here, so you know we're going to add them. The 2g squared plus g squared becomes 3g squared.
Yes,
But if you look in the answer, only one of them has 3g squared.
yes,
Right? B. So if you really wanted to go fast, you could do just these two, and you know it's B. And you don't have to do the rest. Because it's a multiple choice. But you have to feel confident in what you're doing to do that. But it's like if you're wanting to do like shortcuts. Yeah. But for now, I want you to learn the math. But I'm just saying,
yeah,
when it comes time, there's two things. Like one is you need to know the math. But the second is learning how to take these kind of tests. Right? SATs are like this. GEDs are like this. If you're doing anything in the American system, they have this like test-taking strategy. It's the same as like I said, if you have 2 minutes left, you just do everything C, right? Or everything A or something. You get like you get 25% of them right. You know, it's just like you kind of sometimes it's the strategies for taking tests. So right now I'm teaching you the math, but also I want to like just highlight some strategies sometimes. So if you can see things like this, like quickly, you can do it. Or maybe you've done it this far, and then you got to this one, and then you like 3G, and you look at it, oh, 3G, that's what I need to worry about. All right, any questions on that? This is the end of the review. We're going to start a new lesson after this.
it's okay.
You guys ready? Okay.
Can go to the
Yeah, we're going to have a break. I'm just going to take a picture. Yeah, you guys can have your break. We'll have 5 minutes.
start something else.
Yeah, we'll get back to stuff like
5 minutes square?
that. You can have 5x plus 10x minus 5x, where x equals 100. 10x minus 5x, where x equals 100. Alright. So, today we're going to do multiplying and dividing polynomials. Okay? So it's similar to how we're doing adding and subtracting, but now we're multiplying basically the polynomials are going to be in brackets, and we figure out what we do with that, how we multiply it. So multiply, we'll start with multiplying. So first you remember monomial, binomial, trinomial, do you remember?
Yes. Polynomial.
Yeah, we could go on quadnomial, quintinomial, but we basically just take polynomial after that. So monomial, has how many terms? One, right? Mono.
Yeah.
Mono is one. Binomial, how many terms?
2.
2. Trinomial?
3.
3. Exactly. So when we're multiplying by polynomials, the types you'll have in the GED are monomials times monomials, which are the easy ones. The monomial times a binomial, which is a bit harder, but not too hard. And then binomial times a binomial, which is the more complicated one. But you can continue. You could do like any length of polynomial times another polynomial. But then you have to multiply each term across. And I'll show you how that works. But let's start with monomials. So monomial times monomial. So basically, if I have a monomial here, it would be like 7 squared, right? And the other one can be 3ab to the power of 4. Right? So here's my one monomial, and here's my other monomial. And if I multiply them, I'm basically saying 7 squared times 3a. So now what we're doing is we're multiplying across the board. Okay? So what you're doing when you do that is you first multiply the coefficient, okay? And then every variable, if it's the same variable, you add the powers. Okay? So this is a squared and this is a. So a squared times a equals a cubed. Alright?
Yes.
So I can show you that with an example. 2 squared times 2, right? That's 4 times 2 equals 8, right? That equals 8. Same way then, and 8 equals 2 to the power of 3. Right, you see that? Pardon?
21.
You need to add
To the power.
So when you multiply a variable and it has a number, when you multiply any number and the number has exponents, you add the exponents. Okay, so it's kind of like a step up. And it's sort of, if you think about it, right? 2 plus 2 plus 2 plus 2 plus 2 equals 2 times 5, right?
Yes.
And here, because we're doing it 5 times. 1, 2, 3, 4, 5. Right? Because this is 10. It's the same as 2 times 5.
Yes.
Right? So it's like a step. And if we, let's see how I'm trying to say this. If you multiply, yeah. So say we take, in brackets, 2 plus 2 plus 2 times 2 plus 2, like this, right? This is 6 times 4,
Yes.
which equals 24, right?
Yeah.
Or I could see it as 2 times 3 plus 2 times 2, right? Yeah, this isn't quite working the way I wanted it to work though. Yeah, so I was thinking it would be times 3, we'd be able to do 4 times 5, that's not quite right. My example's not working, so never mind this example.
Yeah.
That's not quite working. The powers are sort of like similar. So if we do 2 times 2 times 2 times 2, that equals 2 to the power of 4. Okay? That makes it this. Right? And when we multiply if you think about it, if you have 2 times 2 times 2, right, times 2 times 2, like this, right? This becomes, we can either see this as 2 cubed
Yes.
times 2 squared, but you can see, you can just count them, right? 1, 2, 3, 4, 5.
Yes.
It's a little bit low for you guys. Alright, so this equals 2 times 2 times 2 times 2 times 2,
Yes.
or 2,
To the power.
3 plus 2, which equals 2 to the 5.
Yes.
Okay? It's the key concept with exponents. And basically you're moving
Yes.
into the power, it's a plus. Right? This is why when we multiply variables, the variables we don't know that it's a 2. But we do know it's the same number. If it's an A here and an A here, whatever A is, it's the same number. If A is 2, it's 2 here and it's 2 here. If A is 7, it's 7 here and it's 7 here. So we can do this kind of trick with it. Right? And then we can add the exponents. So this here, basically, my explanation, this will equal 7 times 3 times A squared times A times B to the power of 4. Okay, I'm just putting them together.
Yeah.
And 7 times 3 is what?
21.
21. Now A squared times
A cubed.
A cubed. And B, we don't have anything with B, so it becomes B to the power of 4. So you see that? So the answer of this monomial, 7A squared times 3AB cubed, B to the 4th, is 21 A to the 3rd, B to the 4th. Right? And one thing is sometimes if you're kind of unsure if it works, you can substitute numbers in
Yeah.
the first one, and we can do it out. So let's say, just to check it, let's say that A equals 2, and B equals 3. Okay? So if A equals 2 and B equals 3, then 7, 2 squared, right? And the other one is 3 times 2 times B, oh man, to the power of 4. That's going to be a big number. Okay, anyway, so this is going to equal 7 times 4, which equals 28, right? And this one equals, oh no, this isn't B, this is 3 now, right? So this is 5. Who knows what B to the power, 3 to the power of 4 is? Not quite.
27 times 3.
27 times 3, because 3
Yeah.
and then 9 is 3 squared.
Yeah.
9 times 3 is 27. What's 27 times 3?
91, right?
81.
81, yes.
The other way you could see it is 9 times 9. Right? So it's 5 times 81. No, it's not 5. 6 times 81. Alright, how would you do 6 times 81 in your head?
400 and 68.
66.
66.
66.
6 times 1 is 6.
Yeah, so you do 6 times 80,
Yeah.
which is 400, is like 40. 6 times 8 is 48, right?
48. Yeah.
So 480 plus one more, so 486.
486, I said.
486. And now we need to do 28 times 486. We might need a calculator for that. Alright, so 28 times 486. You know, I'm just going to do that on a calculator because that's too much. I should have used a smaller example.
And the power is bigger. Power is big number.
Yeah, I know. Even little numbers get big. Times 286. So this equals 13,608. 13,608. Or we can put it in here. 21. You can just put this in your calculator. It's good practice, actually. I said that A was 2 times 3 to the power of 4. You guys remember last week? Calculator practice?
Yes.
Yeah? Let's try it. So this one,
Okay.
21 brackets, 2 close brackets, x with a little square, 3, and then you have to make sure you push the 5 to the front again. 3, also an x squared 4. I'll send that to you guys. That's of course.
Yes, exactly.
Alright. So that equals 13. Putting the comma there.
Yes.
13,608.
13,608.
Yeah.
Yes.
So you can see this times this equals 21 a cubed b to the power 4. Right? So this one's maybe a little bit more complex. So I'll take a picture of it and then I'll do a more simple one. Just so we can stay consistent. We can okay. I'll erase that. Alright, let's try 2x times 5x squared y. Okay? 2x times 5x squared y.
2x.
2x times 5x squared y. So the first thing, we multiply the coefficient, right? So it becomes 10. And then we look at each of our variables.
X cubed.
Okay?
Cube.
Exactly. So here's an x and here's an x squared.
Yeah.
So it's multiplying, so then it's going to become x cubed. So there's no y. Here's the y. So the y just stays.
Yeah.
So it becomes 10 x cubed y. And it remains, it's one term. Okay? So when you're multiplying a monomial, whatever the second one here, how many terms is here, that's how many terms you will have in the end.
1, 3.
So this is 1. Okay? So if this is a monomial, and if this is a monomial, so it's going to be one term. Monomial plus monomial equals monomial. Then multiply. Monomial times binomial will be a binomial. So let's do another example of this. So let's say we have 2xy times 7yz squared. Okay. So first is 14. We multiply the coefficients, right? 14. And then have x here. Do we have any x's here?
No.
No. So the x just stays.
Y squared.
That's right. There's a y here and a y here.
Y squared.
So if it doesn't have a power, it has a 1.
Yes.
Okay? So y times y becomes y squared.
Z squared.
And then there's no z here, but there is a z. One way you can imagine this is it's actually the same as 2x to the power of 1, y to the power of 1, z to the power of 0, times 7, x to the power of 0, y to the power of 1, and z to the power of 2. Okay? This is the same as this.
Yes.
Because any number to the power of 0 is 1. Right? So it's just not here. The same here. X to 0 is not here. And then what I'm doing is I'm multiplying the coefficients and I'm adding here. So x was 1 plus 0 is 1. Right? Here, y1 plus 1 is 2. Here, 0 plus 2, 2. You guys see that?
Yeah.
To help you kind of understand. You can imagine any term as a whole bunch of variables to the power of 0. Right? If it helps you. If not, just go like by each letter. So this is our binomials. Are there questions on this? Huh? Does it make sense? I'll do one more. 4g to the power of 6 h2 times 21 g to the power of 2 h4. Okay? And this dot here means multiply. This is why we don't use the x's anymore, because you think it's an x. Right? Alright.
84.
So first we do the coefficients. So 4 times 21 is 84.
Yes.
84. Next we have a g
To the power of 8.
and g. So here's 6
Yeah.
and here's 2.
Yes.
So we add them.
8.
Okay, so it becomes g8. And here we have h
That's
squared
about 6.
and h4. So we add them as well. 8, h6. Okay? Is that clear?
Yes.
Alright, good. So this is what we're doing with each monomial. We'll move on to a monomial times a binomial. And that's going to be the same, except we're doing it for each term. So I'll show you what I mean. So there's a monomial times a binomial. Example would be 2x times x plus 1. That's a very simple version. Okay? So here's our binomial, this one. So it has two terms. And here's our monomial. Outside, alright? And what you do is the same as if you had 2 times x plus 1, right?
Yeah.
The distributive property. So 2 times x plus 1, I basically multiply this times each one, right?
Yes.
So this equals 2x
Plus 2.
plus 1. Oh, plus 2, yeah.
Yes.
Exactly. So now it's the same here, but each time I basically do a monomial times a monomial for each term.
Yeah.
Okay, so we already did monomial times monomial, but for this one now I do it for each term. I do monomial times monomial.
Yeah.
Okay? So this will become 2x times x.
2x squared
X squared, exactly. So that equals 2x squared
plus 2x.
plus 2x, because that's 2x times 1
Yes.
plus 2x. Okay? That's a simple version. Let's do a slightly more complex. So we have 3x times x squared plus y. Okay?
3x.
It's the same thing. Every time I just take this monomial and multiply it by each term.
Yes.
Alright? So it's 3x times x squared.
3x cubed
3x cubed, exactly. The coefficients add up.
times 3xy
And then this one, again 3 plus
3xy.
3x and y. So just keep them. You guys see that?
Yeah.
Yes.
Good? Okay, good. Let's do something a little bit more complicated. Now we'll do 4x squared times minus x plus x cubed. Okay?
Yes.
So first we do this one. So here we do, again, this one times each term. Okay? So it's 4x squared times minus x.
Minus 4.
So the first thing is minus 4.
Yes.
Because 4 times minus 1.
Yeah.
So that equals
Minus
minus 4. And we have x squared and x
Yes. Cube.
cubed.
Yes.
Right? Because 2 plus 1.
Yes.
Now how?
X cubed. So
Plus.
here's x squared.
Yeah.
And this is x.
This is y, huh?
No, it's x. It's
No,
x. Sorry.
Ah, okay.
Yeah, x. So it's x squared times x. So this is a 1. So 1 plus 2 is 3.
Yeah.
And then we do the next term. So 4x squared times x cubed.
Plus 4. X
So we have
to the power
plus
5.
4 and x squared plus x cubed
X
becomes
to the power
5.
Yes.
Right? Becomes x
The power of
5 to the power x to the power 5. You see that?
Yes.
So we started here, this one is 2 terms. We end up with 2 terms. Alright? This is multiplying through. So basically, the whole point of multiplication of polynomials is that every piece has to multiply through with every other piece. Okay? Let me do another one. 3x squared times 2x minus 5y. No. 5x. All right. Again.
Yeah.
So this is 3 times 2.
Yes, 6.
Six.
X to the cube. Yes.
X is 2 times x is x cubed. That's right.
Minus
Now 3 times minus 5.
minus 15.
Minus 15.
X cube y.
And now here x squared times x. That's right.
Y.
And there's a y. Any questions on this? For a monomial times a binomial. Follow it through. Any questions on it? I'm going to go on to binomial times binomial. Yeah? Okay. Good. All right. The next one is binomial times binomial. Right, so a very simple version would be x plus 1 times x minus 3. Right? This is a binomial, this is a binomial. And now what we have to do is each term of this binomial, we have to multiply by each term of this one. So you're going to end up with more terms. Alright? When it's with more terms here, you're going to have more. So what we do is we start on this side and on this side. So we start here. Here's an x, and multiply it through. So basically, remember when we had just the monomial times a binomial? It was basically having a monomial times a monomial and a monomial times a monomial.
Yeah.
Now we're doing a monomial times a binomial and another monomial times a binomial.
Yes.
Okay? So we start with this term. So it's x times x. Okay?
X
So
squared.
this equals x times x is x squared.
Yes.
Then we go on the next, we stay on this one and the next term here.
Yes.
Okay, so x times minus 3.
Minus 3x.
Minus 3x. Now we can move on to the next term of this one. So 1 times x.
Plus x.
So this is plus x. Okay? And then 1 times minus 3.
Minus 3.
Minus 3. Okay, so you see that? So this one here is the product of, it's basically like having x times minus 3 plus 1 times x minus 3. You see that? We took this one, multiplied it through, and we took this one, multiplied it through. And so we basically just became, this one here became this answer, and this one here became this answer. And now we have to simplify. This is the key point when you do binomial times binomial. Often in the middle you will have the same like terms.
Yes.
So you have to simplify them.
Yeah.
Okay? So here we have x squared,
Minus
and here we have an x and here we have an x.
minus 2x.
So it becomes minus 2x
Minus 3.
minus 3. Okay? This is your simple form of binomial. Let's try a little bit more complicated. 2x plus y times x minus y. Okay? It's the same process. We start here with this term. We multiply this term by each one. Okay? So first thing we do 2x times x. What is that?
2x squared.
So that equals 2x squared. Okay. Honestly, but now that I'm doing this, I feel like now we're doing algebra. Now we're into it. Okay, so 2x squared, and then what's 2x times minus y?
Minus 2xy.
Minus
2xy.
xy. Exactly. Alright, so we've done this term. Now we do this term. Okay? So it's going to be plus whatever this is. This is plus. So plus y times x is what?
xy.
yx. It's also the same as xy. 2 times 3 is the same as 3 times 2.
Yes.
So it's going to be easier for us if we keep it as yx or xy, because these are going to be the same. And then here, y times minus y.
Minus y squared.
Minus y squared. It's not like when we're adding and subtracting, right? You're not canceling them, we're multiplying them. Okay, so it's a plus 1 times a minus 1
Yes. Minus
becomes negative
y
y
squared.
squared. Alright, are there any common terms?
Yes.
Yes.
These two, the xy,
Yeah.
right? So this is going to be
2x squared.
x squared.
Minus
So minus
xy.
2 plus 1 becomes minus 1.
Minus
xy.
xy
Minus y squared.
minus y squared. You see, your typical format for binomial is that you have 3 terms in the end. Okay? And actually, if you multiply a binomial times a trinomial, I think you get like 5 terms in the end. Or 4 terms or something like that. And there's a mathematician, his name is Pascal. He made like this Pascal's triangle, like showing how many terms come through. It was like used for early computing. It's like 2 becomes like 3 terms. And I think like 3 times 3 would become 5 terms. And it's like 4 times 4 would be like 7 terms or something like that. It was like a formula. Number of terms equals total terms minus 1 or something like that. But you guys don't need to worry about Pascal's formula right now. Maybe if you do some computing later, you'll learn it. It's like theory. It's called the binomial theorem, actually. Okay, so this is our example here. And let's do another more complicated one. Let me take a picture of that. So, squared plus 4b times b squared. Ready?
Yeah.
Alright, so a squared times b squared.
A squared, b squared.
A squared times b squared, okay? Because we're multiplying them.
Yeah.
So that's this one times this one. Now we do the next. A squared times negative a.
Minus a to the power of 3. Okay.
Minus a cubed.
Yeah.
Okay, so that's this one. Now we're going to this one.
Yeah.
4b times b squared.
4b cubed.
4b
Plus.
cubed.
Yeah.
And now 4b minus a.
Minus 4ba.
Minus 4. I'm going to go ab.
Okay.
Just to keep them consistent. Are there any common terms?
Yeah.
Any like terms? I have AB here. Where's the other AB?
No.
It's not. It's A squared, B squared.
No.
So this doesn't actually simplify.
Yeah.
Alright?
But how many times? It's 4 times.
Pardon?
4 times.
There are 4 terms, yeah. So it doesn't actually work as nicely. It's not the right format. I did make some complex stuff. I thought I answered the question. No? Okay. So let's try some other stuff. Now, what if we have xy squared, say 2xy squared, plus 1, times y minus 3xy. Let's do it divide here. Yeah, we'll do like that. Now I have multiple variables in my terms. But it's the same principle. It's the exact same principle. You just do this one times each one and this one times each one. Okay? So this equals 2xy squared times y.
2xy cubed.
Exactly. 2x
Y
y cubed.
Yeah.
Okay? And then we go here.
Minus.
2xy squared times minus 3xy.
Minus 6
Minus 6.
x
So minus
cubed,
6 x times x is what?
squared.
X squared, that's right.
y
Y squared times y.
y cubed.
Y cubed. Alright, good. Now we go on to the next one.
Yes.
Right, we're going in the first, you term in the front.
Yeah.
You're 1, 2, okay? So now y times y
Plus y squared.
plus y squared. Okay, and y times negative 3xy.
Minus 3 3xy squared.
3xy squared. Okay. Do we have any common terms?
Yes.
No.
The first one,
This is
Minus
y
3xy
cubed.
No.
6.
I should have made this a 1 and then
no.
No.
No, this is it. If there are common terms, you can cancel them.
No.
Probably in the questions they'll give you, they think about them ahead of time, they make them a little nicer so you can cancel them. Any questions on this? It's basically the same method. You always use the same method over and over. Yes and no.
No, it's okay.
You just look kind of like, you'll practice some more, you practice,
No, it's
and you'll
okay.
get it. Let's do one more.
I think it's 4 times. No, it's
No, it's 4. It's 4. It's 4. 1, 2, 3, 4. Yeah. 4 terms. Alright, let's do 7g squared minus 3 times 4g let's do 4h plus okay? No lines between these. Alright. So, here are two polynomials. We start with this one, right? 7g squared times 4h.
28.
28
28 g squared h. Yep. Okay, now the next term. 7g squared times g squared.
7 to the power 4.
So plus
Yes, plus
7 g to the power of 4. Okay, so that's this term done. Now we do this one. It's minus 3.
yes.
So minus 3 times 4h.
Minus 12 h.
So minus 12h. Okay, minus 3 times g squared.
Minus 3 g squared.
Minus 3g squared. Again, doesn't simplify. Alright, I've been choosing some bad examples. But I think you get the idea, right?
Yes.
Okay, good. Because now we're going to go on to dividing polynomials. Picture of that. Yes. Same power. You mean of this one? Yeah, it has to be the same variable and power and altogether the same ones. So this one has a g squared,
Yes.
and this has g squared, but this has an h. This does not have an
No,
h.
these are power of 4.
And this is power of 4, but this is power of 2. Yeah, there has to be the exact same combination of variables and powers in each term. Yeah, okay. So, now we will do dividing polynomials. Okay. So you can divide by a number. Or divide by a polynomial. Okay? And the GED is going to be a simple polynomial. If you do divide by polynomial, it will be a simple one. It will be like a binomial with not too much complications. But let's do this one first. So, for example, if we have 5x plus 5 over, let's do 15x plus 10 divided by 5. Okay? So what this equals is the same idea, but we divide each term. Okay? This is the same as 1 over 5 times 15x plus 10. Okay? So if you recall, because of what a fraction is, like the relationship between fractions and division, anytime you divide by a number, it's as if you're multiplying by 1 over that number. And then you just do the same principle that we did with multiplication, right? So it's 1 over 5 times 15, which is basically 15 divided by 5, right? Just 3x. 1 over 5 times 10 plus 2, right? Or let me do the in-between step, just to make it easier. So this equals 15 over 5 plus 10 over 5. I basically distributed this into the equation. Okay? Or you can see here, 5 goes here, 15 over 5, 5 goes here. Okay? Say we have one where it doesn't work out as nicely, which equals x. Oh no, there's no x here.
We need to divide to over them.
Pardon? Yeah, because this is the whole thing is divided.
Okay.
Right? You could also write it. You could also see something like 3y plus 7 divide by 3. Something like that, right? Right? And then this would become 3y over 3 plus 7 over 3. So distributed into each one. Okay? And that equals, well, 3 and 3 cancel, becomes y plus 7 over 3. Okay? Because you just leave this one as a fraction. If you can't divide the number, leave it as a fraction. But the important thing is you do each term. So this is very similar to dividing, like multiplying by a monomial. Right? Let's do another one. Say we have 12x squared y plus, let's do, plus 10x. And we're dividing this by 2. The whole thing divided by 2. Okay? That equals basically 12 divided by 2, 6x squared y
Plus 5x.
plus 5x. Exactly. Any questions on this? This is just dividing by a number, right? There are no questions on that, then we're going to go on to dividing by polynomials. Oh wait, I wanted to show one other thing. For example, this one, there's one other way you could see this. Okay? And that is that 15x plus 10, we can use the inverse distributive property to pull the 5 out, right?
Yeah.
So we can just say immediately that equals 5 is 3x plus 2, right?
Yeah.
So then if this is over 5,
Yeah.
we can say this is over 5, and then these 5's cancel. Alright? And it gives us 3x plus 2. This is going to be key when you're solving these problems, using the distributive property to pull out the common term. Take a picture of that as well. So now, what if you're dividing by more than a number? What if we have 7x squared minus 3x divided by
7x.
Yes, 7. Distribute the products in there. It is 7x minus 3.
Yeah. So it's the same. Imagine if I had 28 minus 12 minus 6, right?
7x.
Over 2, right?
Yeah.
I can say 28 over 2, that becomes 28 over 2 minus 6 over 2, becomes 14, right? And becomes 3. We cancel because there's a common number, right?
Yeah.
We're canceling these because there's a common number. It's what we remember from fractions. But if we have x here and x here, it doesn't matter. We don't know what x is, right? That's the key. That's what algebra is. We don't know what x is. But what we do know is x is always the same. Right?
Yeah.
If x is 2, it's 2 here and 2 here. So that means I can cancel common x's.
Yes.
If I have a variable on the top and a variable on the bottom, I can cancel it. If I have a variable squared on the top and a variable on the bottom, it comes down by 1. Right? If I have x cubed over x squared, right? This is like 8 over 4. Right? It becomes x. Okay? That's what I do here. So basically, I'll do a distributive property. So this becomes x times 7x minus 3 all over x. Right? I pulled the x out. Because x times 7x is 7x squared. X times minus 3 is 3x. Right? And now we have an x on the top and an x on the bottom. So I cancel them. And it equals 7x
Minus 3.
minus 3. Alright? This is the key to doing these kind of problems. So if you have a polynomial at the bottom, and this is most of the ones you're going to be getting are pretty simple polynomials. Okay? Like a monomial like this. You can just divide it out. Take a picture of that. Let's do another example. How about 5 squared y minus 3xy all divided by, let's make this a little bit easier. Let's do minus 10xy all divided by 5y. Okay? So what we do is you'll often see in a lot of these problems, if you have this at the bottom,
Right.
you can probably take that out from the distributive property as well. So it's just a trick. A lot of times they write problems to make them easier for you. So there's a 5y here, we have a 5y in here,
Yes.
and there's a 5y in here, right?
Yes.
So there's a 5 and a 10.
Yeah.
So if we take the 5y out of here, right, there's 5y,
It remains x
x
squared.
squared remains,
Yes.
right? 5y out of here, it's minus, 5 and 10 is 2,
Then
and what remains? X.
x 2x.
All over 5y.
5.
Okay? And now these can cancel. And we're left with
X
x
squared
squared
minus 2x.
minus 2x. Now it's possible you could have taken an x out of here as well. Let me do that actually. Let's do it that way. There's a common 5xy in both of them. 5xy, and we're left with x minus 2. Okay? And here the 5 cancels,
Yes.
and the y cancels.
Yes.
And now we're left with x
X times x minus
times x minus 2. And then we can put that back together. X squared minus
2.
using our multiplying. how about y is 3y plus 6 y over, let's do y squared, y plus 2. Now this is a more complicated polynomial, right? It's not a simple monomial, you're actually dividing by a binomial. Now the thing is, try and do the distributive property again. Okay, so this time we have 3y squared, right?
Yes.
And this is 6y.
Yes.
So what are common things? There's a 3 that's common, right?
3y.
And there's a y that's common.
Yes.
So we take the 3y out, what is left? So
Y.
3y squared divided by 3y gives you just y.
y plus 2.
And this one, exactly, plus 2. All over y plus 2. Guess what we can do?
Yes.
We can cancel the y plus 2.
Y plus 2. Y.
Do you guys see that? This is a key move for the homework you're going to be getting. Alright? You simplify this, sometimes it'll simplify to a polynomial that you can cancel. Right? If it's the same polynomial on top and on bottom, you can cancel them out. I'll do another one like that. Let me take a picture. So I'll do two. I'll do one in between step, and then one step. Okay, so say we have 6y times x plus 3 minus 2 times x plus 3, all divided by x plus 3. What do you think is going to happen?
6y minus
X plus 3 can be
Pardon? This is the y.
6x minus 2.
So you can divide each term, remember here's a minus, you can divide each term by x minus 3. So these are going to cancel,
Yeah.
right? So this is going to get you 6y
Minus
x plus 3 over x plus 3, right?
yeah.
Minus 2 x plus 3 over
Over
x plus
plus
3.
Yes.
These ones cancel, these ones
6y
cancel.
minus
We get
6
6y
minus 2.
minus 2. Alright, do you see that? In between stage. So now, let's say I have 3y squared. No, we already did that one. Sorry. Say I have 14xy, x squared y, minus 7 xy, all divided by 2x minus 1. That's minus 1. I think that works. This one is hard.
7xy.
This one is hard, yes.
7xy.
Right, so the first thing is we need to simplify this.
Yes.
Right?
Yeah.
Find your common number. So we have a 14 and a 7.
Yeah.
7.
So that's going to become 7 something, right?
Yes.
What else do we have? We have x here, x squared, and x.
Yes.
So we know there's an x.
X.
And we have a y and a y. So
Y.
the y comes out. 7xy. So now 7xy times 1 equals 14.
2.
2,
2x.
2x,
1.
right?
And minus 1. Yes.
And then this one, 7xy is just minus 1.
Minus 1.
all over
2x
2x minus 1. You see, I made this problem for you.
Yeah.
Okay, and so this cancels,
Yeah.
and you get 7xy.
That's right.
A lot of the problems are like that. If you see something hard like this, they probably made it so that it'll cancel out. Not always, and in real life never. But in math tests and in like exercises, often it's like that. Okay? Now you can get more complicated with this. For example, this problem here, this thing up here, you probably won't see this, but this is the same as 6y minus 2 times x plus 3. Right? So it's basically 6y times x plus 3 and minus 2 times x plus 3. So this is kind of like the second stage of a binomial multiplication. Alright? So you might see something like this, but if this is over x plus 3, you can cancel these ones immediately. Right? And you get the answer here.
Yes.
That's one way you can do it. You can put these together. But the thing, the distributed property is so powerful in algebra that it moves them in and out of brackets and putting them through like this. Now, at some point, this problem can also be written this way, which would be we actually multiply it out. So we'd have 6xy minus 2x, right? No, sorry, 6xy plus 18y minus 2x minus 6 divided by x plus 3. Alright? And if you solve this, that would look very complicated. But it actually, you'd be able to simplify it. It would be kind of hard. And I don't think you're going to get any exercises like this. But if you could put it back to this level, then you'd be able to do that. And in fact, if you do get an exercise like this, the fact that they've given you something like x plus 3 on the bottom, maybe you can think, well, maybe it's something times x plus 3 to cancel out. And it's just and you say, okay, the top is x plus 3, that's what times x plus 3. So I don't think you're going to get a problem like this. But there's one other problem, one other issue. And that is, what if we have something like, what is the example? Yeah. X minus 1, x plus 1 over x plus 1. But they tell you x equals minus 1. This is a mathy kind of question. Because we could say we can just cancel these out, right?
Yes.
We'll get x minus 1. And minus 1 plus minus 1 is minus 2. But there's a problem. Because what if we just put it straight in? Minus 1 plus 1 is 0.
0.
And if we divide by 0, what happens?
0. Good.
The computer crashes. Right? So actually, the answer to this is undefined. Because even though we can simplify out, we're starting with something that's dividing by 0. Okay, so this is undefined. Whenever you have a 0 on the bottom, it becomes undefined. But it's only because we know x is minus 1. Okay? So this problem we can probably solve out because we can get rid of these without worrying about it. But if we don't know, say this is like, this is minus 2. X plus 2 minus 1. Something like that. It's undefined.
Sure. What about another question?
Yeah?
We can simplify.
This one?
Yeah.
I just took it from here.
I took it from out.
Yeah, I basically, because I said this is a binomial multiplication, so I just multiplied them. So it's 6y times x is 6xy. 6y times 3 is 18y.
Oh, it's okay.
Minus 2 times x is minus 2x. Minus 2 times 3 is minus 6. So just showing, I kind of worked backwards. But you could get a problem like this, you have to work forward. Just to show you how they're all related. Now, I think it's about time. So for your homework, it's basically everything on 245 and 247. So then you write that here.
3, 4, 5.
Yeah, homework, page 345 all. And I want you to practice these. Page 347 all. Okay? And give yourself some time for it because these ones are harder than we got last week. I think you can do it. You guys are on it. But give yourself a little time. The division, I think, is going to be, it's all right. This is the thing. We'll go over it again next week. So you'll have some time. Okay. Have a good week.
Thank you.